Alright, what's going on, you guys? Another LeetCode video today. This one's called max area of island. So we're given an m by n binary matrix called grid. An island is a group of ones representing land connected four directionally, just horizontally or vertically. And we can assume that all four edges are surrounded by water, right, of the grid. So the area of an island is the number of cells that have a value of 1 on a given island. So they want us to return the maximum area of an island that's on the grid. So just looking at this first example here, they have a nice illustration here. We're basically just counting up the area of each island and then returning whichever island has the maximum area. So we can see like this island, this would be an island, it has an area of 1, so on and so forth. This island has an area of 4. And we could look at each island, but I think, an important example here is notice, these are going to be two separate islands. This island of, this island of 6 and this island of 5, right? Because even though they're diagonally adjacent, the only adjacency that makes an island is just horizontal and vertical adjacency, right? So these are two separate islands, and this example case would return 6, right? Because this island that has 6 ones is larger than all of the other islands. So yeah, let's get into the whiteboarding for this problem. So the way we're going to solve this is with a depth first search, where we're basically going to iterate over each cell in the grid, and then at each cell try and do depth first search, as long as we have not already visited that that cell of land, right? So, and we're going to keep track of that with another 2D grid. It's going to be the same size as the input grid. It's going to have booleans in each position that just indicate whether or not a cell has already been visited or traversed, right? Whether or not we've already searched that space, because we don't want to do any work twice, right? And we want to be able to keep track of what cells we've already looked at for this algorithm to work at all. So we're going to start in the top left corner here, and the way our depth first search is going to work is we're actually going to have a return value, which is going to be the area of the island we're looking at starting at a given cell. So we're going to search downwards first always. So let's just circle the cell to indicate we started a depth first search here. We're going to mark this as true, right? Because we have visited the cell now. We're going to go down in our depth first search. We're going to mark this cell as true. We would go down this way, but we would see that this is a 0, so we would return. The next way we search is up. We would see that this cell is already visited. So then the next way we would search is to the right. So we see there's a 1 here. So we're going to mark that off in our visited. Meanwhile, we're counting up this area. So this area now, by the way, each of these cells that don't have a 1, once we stop the search, we're going to return 0. And at every other cell, we're going to add a 1 to the return value. So we would ultimately get 3 on this area. So the max area now is going to be 3, because it's obviously bigger than 0. And now we don't have a current area anymore because we're done with this depth first search, and we move on. So we're going to come all the way here, and we're going to do the same process at this island. So, and let's just circle this to indicate that there's an island here. So we're going to look here also. We're going to mark this cell as true because there is land here and we've already visited it. So we're going to go down. We're going to be able to go down quite a bit here in this depth first search. So let's actually illustrate this like it's an island. So we would go down, and we're going to keep going down. We're eventually going to include these, but really we would search downward first as far as we can go, just the way we're ordering those recursive calls. So all of these are going to be set to true, and this is going to have a return value of, let's see, 4, 5, 6, 7. So this area is 7. That's obviously bigger than the max area, right? We're only comparing the size of the island once we've actually calculated the total size. Once we've calculated the total size and it returns from the depth first search, at that point we compare it with the max area so far. So we're not continuously comparing with max area and doing unnecessary work. We're only comparing once we've calculated the total size of an island. So all of these are true. The max area now is 7. We're going to go down to the next row, and we're going to skip over these cells because they're marked as visited, right? So that's how we know we've already counted those cells. So this is the first next cell that has not been visited. It's only got a size of 1, so we do not update the max area in this case. So at this point, we traverse all of the cells, and then the next unvisited cell would be these, and the depth first search. This is obviously going to be the biggest island here. So this is obviously going to be the biggest island here. I'm not going to even bother marking all of these as visited because it's a lot, but let's see. This is going to be 2 plus 4, 10, and then 12. So this area is going to be 12, and then the max area is going to be greater than the max area of 7, right? So the new max area is 12. Okay, so in terms of the time and space complexity, I'm just going to kind of scribble this area because we visited somewhere down there. Anyways, the time and space complexity is going to be, the time is going to be big O of m times n, right? Because we're visiting every cell at least once, and then potentially, coming back over cells, but there's not going to be any kind of weird scaling. At most there could be another constant, like we might visit a cell twice. We might mark it as, so for example, like we marked these cells as visited, but then we came and saw them again. But basically, once we mark them as visited, we're not going to really see any cell more than twice. So we can just say big O of m times n, where those are the dimensions of the grid. For the space, it's, we're going to have this m times n visited data structure, right? And there's also space in the recursive call stack that can be, worst case, m times n, right? So really we would have like 2 m times n here. The constant goes away with big O notation, but still important to consider the space that is required for recursion with this depth first search approach to the problem. So so let's get into the code. So we're going to need a vector vectors of booleans, right, for each cell we've already visited. So we'll call this visited, and let's go ahead and initialize this in one line here. So the number of rows are just we can get that with grid.size, and then to initialize each row is going to be a vector of booleans, and each row, or each vector of booleans, is going to have columns, the size of the columns, right? So grid 0.size, and then those are all going to be false at first, every cell. So then we just need to iterate over the grid, right? So is less than, let's see, grid dot size, that's the rows, plus, and then we've got a loop over the columns. So j equals 0, j is less than grid 0 dot size, j j++. Okay, and we're gonna have an integer called this area, and we'll say, we'll call our function find area, and we're just gonna pass in the coordinates we're at, the grid, and then the cells we've already visited. And then, we also need a max area. So let's say in max area, just be 0 at first. Max area will just get updated to the maximum of itself and whatever that area is, right, from our find area function. So after that, we can just return the max area ultimately. But we've got to actually code this find area function. So let's do that. So let's make it a private function, or a private class method. So it'll have a return value, which is an integer, right? So integer find area, it's going to take those coordinates, and it's going to take the grid. So let's just copy and paste this. And it's also going to take the visited grid. So, and it's going to take that by reference. Okay, so the first thing we're going to do is just check, is this cell, has this cell been visited? Also, is it land, right? Those are the two criteria we need to increment the current area and keep searching. So if grid, and the grid is integers, so we can literally just say if grid, or if not grid, ij, or, we've already visited this cell. So if not grid, ij, or it's already been visited, or visited ij, then we're just going to return 0, right? Because that's like an edge case where, we're not on land, or the land we're on has already been visited, so we don't want to count this. So we're just going to return 0. Otherwise, we've got to mark this cell as visited. So visited ij is going to need to get set to true. We're also going to want to increment the area that we're at. So we're going to make a new variable called this area. We'll just set it equal to 1. And then what we're going to do is, we need to search in all 4 directions, ensuring that we're in bounds. So when we're incrementing I by 1, we need to make sure that stays less than the number of rows before we call find area recursively. But each find area call, it returns whatever the area is, up to that point. So we've actually got to say this area plus equals, we've got to add whatever area is returned to the current area on this cell. And then we just pass in I plus 1, j, grid, and visited. And we do that for each direction. So let's just copy and paste this a couple times. So we also need, well, j plus 1 is less than the number of columns. We're going to increment j plus 1. And we also need to decrement I and decrement j. And the correct equality is, for decrementing, is we need to make sure we're not going out of bounds in the negative direction. So we can just say greater than or equal to 0. And we will decrement I for that, and then for j, we're decrementing j. Okay, so that's all 4 directions. We're incrementing this area, and then finally, to complete the recursion, we have to actually return this area at each cell where we're doing that. Okay, so at this point we would know the area of an entire island once this executes all the way through, and then we can just update the max area with that. So yeah, let's go ahead and submit this. So yeah, hopefully, this explanation of max area of island is helpful. If it is, leave a like and subscribe, and I'll see you guys in the next video. Peace.